you how to calculate the gradient of height. This is the topic related to the RGPD syllabus of subject engineering physics. This subject code is BT201. The unit number 5 is the electrostatic in vacuum. In this subject, we have to calculate the Gauss theorem and the divergence theorem. So in this theorems, in divergence theorem, Gauss theorem, divergence theorem, in all these theorems we have to know that how to calculate the gradient. Because many more times we have used the gradient, divergence and the curl of any field. So how, without we knowing that how to calculate the gradient or what is the gradient of any field, we cannot write the Gauss theorem, Stokes theorem. So that just concentrate here how to calculate the gradient of phi. So before starting the gradient of phi, first of all we have to know that what is the del operator. This symbol, that means the inverted triangle, is known as the del operator. In place of this, the simple upright triangle is also known as the nebula operator, nebula. So opposite of this nebula is known as the del operator. Okay. So what is that? This del operator? Del operator means what is dy by dx of ax. Ax is the unit vector of this field, x field, plus dy by dy of ay, unit vector of y field, dy by dz of az, unit vector of z field. Okay. In place of ax, ay and az, we can also take the dy by dx of vector I. Also we can take this dy by dy of vector j plus dy by dz of vector k. Okay, so this is also a del operator. Okay. Suppose we have a function phi. Phi is the function of any x, y, z component. So if this function or a field, how to operate this del operator on this field? Okay, del phi. Del phi means the gradient of this function phi. Okay, so del phi means how to calculate this. So del phi means dy by dx of phi function with unit vector I, dy by dy of phi function with unit vector j, dy by dz of phi function with unit vector k. So by using this formula, we can find out the gradient of a phi function. Suppose if we have a question, just take one example for how to calculate this gradient of phi. Take one example. Find the directional derivative. Find the directional derivative of phi function. Phi is the function of x, y and z, which is equal to question 2x square y cube minus 3y square z cube. At the point, and this is the phi function, and find out the directional derivative at the point 1, minus 1 and 1. Okay. So how to solve this question? The directional derivative also the same, the gradient of phi. How to calculate this? यहाँ पे find out the solution. Then del phi is equal to dy by dx of phi function. This is the phi function in this question. 2x square y cube minus 3y square z cube. Vector I. फिर plus dy by dy of 2x square y cube minus 3y square z cube. Vector j. फिर plus dy by dz of 2x square y cube minus 3y square z cube. Unit vector k. Okay. Differentiate this term, the phi function, with respect to x. Here we know that here is not x term and y term, but not here the z term. In this term, here is not a x term. So it may be differential, but here is partial differential. Okay. So differential of this term 2 into 2x x y cube minus this term, because here is not available the x function, so it is not able to differentiate, it is equal to 0. So multiply with unit vector I. In this term, differentiate this phi term with respect to y. In this term, here is phi, here is y. In this term also available y. So it may be both terms are differentiable. So 2 into x square multiply differential of this 3y square, then minus this term 3 into 2y square, 2 into 2y into z cube, multiply with unit vector j, then plus this term, here is not available the z term, so differential of this term is equal to 0, then minus differential of this term with respect to z, then it is equal to 3y square, multiple of this z cube into 3z square, unit vector k. K is a unit vector here. Then solve this term again. 2 2 का यहाँ पे हो गया 4xy cube unit vector I, then plus 3 into 2 6 x square y square minus 3 2s are again 6 y z cube unit vector j. फिर plus this term, this term is equal to minus 3 3 actually it is equal to 9 y square z cube, y square z square, unit vector k. So find the del phi or the gradient of phi at the point. The point is equal to 1, minus 1 and 1. Here 1, this one is equal to x, this is equal to y and this is equal to z. Substitute this value x, y, z in this equation, and we get the final solution. Four into x in place of x 1, in place of y minus 1 cube of vector I, then plus in this term 6 x is equal to 1 square, y is equal to यहाँ पे minus 1 का square minus 6 y is equal to again minus 1 z cube is equal to 1 and इसका cube, multiply with unit vector j, then plus this term minus 9 y in place of y minus 1 square and z 1 square, multiply with vector k, then it is equal to minus 1 the cube of minus 1, it is equal to minus, so minus 4 of I, then plus in this term what happened, see square of 1 is equal to 1, minus 1 ka square is equal to also 1, so it is equal to 6. In this term minus again minus 1 and minus 6 is equal to plus 6, cube of 1 is equal to again 1, so minus minus is equal to plus 6 of j. In this term minus plus minus minus 1 ka square is equal to plus 1, 1 ka square is equal to again plus 1, so plus 1 minus 9 is equal to minus 9k. So total answer is minus 4i plus 6 plus 6 plus 12j minus 9k. This is the gradient of phi function. This is the grade phi of given function. What is the significance or the importance of the gradient function? The importance of that gradient function, that means it is the directional derivative, means we can calculate the particular direction with derivative. That means, for example, if we have a temperature or we represent this temperature by using the phi function. So phi function if represent the temperature, then temperature gradient represent the rate of change of temperature with direction. Thank you.